greetings to you, and thank you for coming back. And today we are going to look at a new topic in our AutoCAD mechanical class, and that is assembly drawing. So, at the end of this presentation, we will be able to understand assembly drawing. What are the things that it is required of us in assembly drawing? The things to include, the things not to include, and how should an assembly drawing look like? So we are going to use a few minutes to look at the theoretical aspects of assembly drawing. We're going to understand the rules. We're also going to understand how we will draw them and the guidelines. Then from there, we will pick a question on assembly drawing. Then we will practice it together. So if you are ready, let's dive in. So in today's topic, we are going to look at definitions. We will also look at the views used in assembly drawing, the things to include and not to include. Then we'll also look at standard parts. Then from there, we'll look at the section lines in assembly, working drawing package. So in assembly drawing, there are some key things that we need to take notes, which are the key points, and there are two of them. The first one is an assembly drawing basically shows how the individual parts fit together to make a machine. So anytime we talk of assembly drawing, the goal is to ensure that the individual parts that are given to you, you have to bring it together to form a complete machine or a system. And also to also include a standard part sheet that contains the purchase item. So these are the key points that students need to take notes in assembly drawing. However, we will also look at what standard part is and how we will tackle them. But before then, let's look at the definition of assembly drawing. So, what is an assembly drawing and why do we need them? So, an assembly drawing is a drawing of an entire machine or system with all its components located and identified. So, any drawing that gives an entirety of the system's components and where they are located basically is an assembly drawing. All right, we need to know how to put the machine together in the first place to be able to identify a machine drawing or to be able to even draw an assembly drawing. So mostly the hint is given even in the question. Anytime a question on assembly drawing is given, you'll be given the hint that we want to assemble this thing or that thing. All right. So with the help of the individual parts, you'll be able to combine all of them to form the final machine that we want or the system that we want. So this is a pictorial view of an assembly indicating the various parts. This is a machine that has 9 parts. So at the top right corner is the part list that contains the name, the number of um, parts, the number required, and then the material that is made of. Now, when we come to the left here, we see the machine, we have the part list. Now, it is also interesting to note that we have all the parts in a single view. So anytime you have all the parts seen in the single view, then you are good to go. There's no need in producing the front view or the side view of the assembly drawing. It's usually not important if you can find all the parts in one single view. All right. So you need to examine and analyze your drawing before you even start the assembly. Do I want all the assembly to be in a single view, or do I need extra views to be able to show the other parts? So this is also another assembly, but if you realize we have two drawings now. One is representing the front view, the other is representing the top view. Now the reason is that part number 16, 15, 5, and 3 cannot easily be identified in the front view, but you need to reorient it in the side view to be able to get it. Alright. So this is where the two views becomes necessary if and only if there are some parts that need to be reoriented to be shown or easily identified. If not, a single view is okay. And pay attention to how the balloons are positioned. You realize that They are not clustered. They are all traveling together. It's either it is in a horizontal manner or it's vertical. Let's look at a sub-assembly. So a sub-assembly is basically two or more parts that form an assembly. All right. And basically think of examples around you. We have a car engine. So a car engine is just a sub-assembly of the car itself, the automobile or the vehicle itself. We have the braking systems, we have the gears and all of that. These are all sub assembly that come together to ensure that the car is able to function. We have a bike derailleur, we have a compressor in an AC. These are all examples of sub assembly in any assembly we have. Now, for us to be able to appreciate assembly drawing, these are some of the commonly asked questions that students do pose. Does an assembly drawing normally show size? And the answer is no. The job of an assembly drawing is to locate parts. When we talk about the size here, we are talking about the dimensions and all of that. All right. In an assembly drawing, there is no need to bring the dimensions. All you need to do is to bring the part itself and how they all come together to form one complete system. All right. How do we show the size of an individual part? So that leads to the detailed drawing. The detailed drawing is a drawing of the individual parts, which includes the orthographic projections, right? So for the detailed drawing, sometimes you are required to produce the two necessary views, either the top view, the front view, or the side view, depending on what you want to do. All right. So the detailed drawing includes the dimensions, all the necessary tolerance if possible, and the things that are required to show us the detail of a particular part. Now let's move to working drawing. Now, right from detailed drawing, we come to working drawing. Now, the working drawing is when we are now ready to manufacture our machine or our system. All right. So, with the help of the working drawing, which contains the detailed drawing, the assembly, and everything coming together, we basically are gearing up or basically preparing for manufacturing. So that is what the working drawing is all about. It's a combination of the assembly and also the 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 details and the standard parts coming together to ensure that we have a complete drawing ready for manufacturing. And the drawing order. So the drawing order basically talks about the package, um, the right presentation of the order with respect to the working drawing. Okay. And let's move on to assembly drawings or views in assembly drawings. What are the views we normally use in assembly drawings and how do we use them? So, does an assembly drawing need a front, top, right side view? The answer is sometimes. It is not always all the time that we have to draw the front view, the top view, the right side view. Like I said in the previous slides, if all the individual parts can be identified in one single view, then you are good to go. You just need only one view. But if not, and you need another view to complement it, then you either produce the top or the right side view. Another question that students normally come across: do we need as many views as it takes to identify the locate each part? And the answer is it may only take one view. All right. So in assembly drawing, we don't have a situation where we draw the front view, the top view, the right side view, and all of that, and we are trying to assemble it. No, the goal is to make sure we bring all the components together. But if some parts are such that you need the right side view, then you need to produce the right side view drawing so that you indicate where the part is. So this is a drawing that requires all the views: the top view, the right side view, and the front view. All right, because if you look at parts number 2, 10, and 9, they cannot be easily identified in the front view. All right, so you need to be able to reorient your drawing in such a way that other parts which are difficult to locate in a single view can be captured. Let's look at this particular drawing where all the parts are in a single view. There was no need for front view or a side view here because all the parts that we need for this drawing can all be identified in a single view. So that's the difference, okay? Let's look at section views. Section views are used quite often when drawing assemblies. And why? Um, for section views, the goal is to show the internal part of hidden components of a machine. So for this particular side, I would recommend you to the previous slides that we have on section views. Try and get the videos and try and get the understanding of section views, because from that, having that as your basis, then you'll be able to appreciate how section views are implemented in assembly drawing. It's just the same principle, just that this time around you have different materials or different components coming together to form an assembly. So we have this particular drawing where we are supposed to produce the section view. So we have the cutting plane indicated there, and like the rules in section view, we draw the sectional view adjacent to where the cutting plane is, depending on the type of projection that we are having. If it's a first angle projection, we know where to place it. If it's a third angle projection, we know where to place it. I'll still recommend you to the slides that we have in this particular class. Get the slides on section views and also the videos on section views, and you'll be fine. So let's move to assembly drawings, the things to include and the things not to include. This is very, very, very important. So the things to include when deciding what to include in an assembly drawing, remember two things, right? One, the purpose of an assembly drawing is to show the individual parts fit together. All right. And it's not used as a manufacturing print. An assembly drawing doesn't necessarily mean that we are ready to manufacture our part. It's just a pictorial view to give us how the individual components come together to form a complete system. All right. And the assembly drawing should not look overly cluttered. All right. It shouldn't be clumsy. We have part number two traveling somewhere, three is somewhere, four is at the east, five is at the north, and all of that. They should all be grouped in a like fashion manner. We'll see that in the subsequent slides. Do we include hidden lines? Again, this particular topic falls under section views, and I would recommend that you do revision on section views and then you'll be able to understand why. So the answer is usually they should be they should be used wherever necessary for clearness, all right? And they should be left off when they impair clearness, all right? And when a section view is used, hidden lines should not be used in that view, all right? Very, very important. This is a rule under section view. The dimension, do we include dimension? A very common mistake that students do make. And as a rule, dimensions are not given on assembly drawing. This is very, very important, and you need to take note of that. If dimensions are given, they are limited to some functions of the object as a whole. All right. So we don't include dimension in assembly drawing. It's not necessary. Let's look at identification, which is the ballooning. And the ballooning is where we have the circle with the number inside. We'll look at how to practically engage and use that using the AutoCAD mechanical software. So this is a pictorial drawing of all that we are talking about. We have the part list, we have the balloons, we have the sections, we have the cutting plane, we have the necessary views all combined together to help us understand what we are doing. So if you look at the balloons, the numbers are contained in the balloons, right? The circles, right? And they are mostly close together. It is either in the horizontal manner or they are in the vertical manner, all right? So pay attention to the orientation you want to use. Either you want it vertical or horizontal. So again, this is a detail to show you the various things that we are looking at. The balloons are placed in orderly horizontal or vertical rows. So the balloons is either you have them arranged horizontally or you have them arranged vertically, depending on what you want to do. Okay. And another rule is that the leader line should not cross, okay, the ballooning lines or what you are using to indicate the path should not be crossing each other. They should be parallel as possible. Now these are petty rules that normally comes back and come and hand students. So pay attention to that. Then the part list, okay, is an itemized list of parts that make an assembly machine or assembled machine. All right. So this is just an example of the part list. We have them here. The part list basically shows the size, importance, the material, the weight, and all of that. And with respect to the position of the part list, we normally position them at the corner. All right, so either the top right corner, top left corner, or sitting right on top of the title block. Okay, so depending on where you want to place the part list, that is the way to go. Let's look at very important subtopic, which is the standard part. And let's try and answer some questions. The standard parts basically include any parts that can be bought off the shelf, right? So, for example, when you are designing a machine, there's no need to design, and you are looking at the individual component and you are considering, let's say, a screw. You don't have to design or model the screw, except the screw is a special kind of a screw. You can easily get it anywhere depending on the size, the function, and the specification, and then you go and get the screw and then use it. So there normally for standard parts, we don't need to draw it. So they don't need to be drawn. Purchasing information is given on the standard part sheet attached to the back of the working drawing package. So this is the standard part sheet. Normally, we include it to our working drawings to tell us that the number of parts, the standard part is the name, this is the description, this is the information needed to be able to identify it and all of that. So this is a sample of a working drawing, and like I said, the working drawing comprises of the assembly, detail, parts, everything coming together, ready for manufacturing. So we have the drawings, necessary views provided. We have the part list also provided here. All right. Then we fill the part list with the names, or we have the balloons indicating the parts. And we also have the dimensions of that and all of that. I know we have understanding in dimension, so there's no need in dimension it. So thank you very much. We'll end here, and I hope to see you in the next video where we'll pick a question, then we solve it together. Thank you and have a nice day.